So the big picture for this lesson is absolute value functions. So here's a graph of an absolute value function, and before talking about this in detail, I want to review what absolute value is. Absolute value is the distance from 0 on the number line. So the absolute value of 4 is simply 4, because 4 is 4 away from 0. Absolute value of negative 4 is also equal to 4. So basically, to make this graph, it's kind of two pieces, because for 0 and positive values, the input is the same as the output, because that is the distance it is from the number line. But if you have a negative number, like say negative 4 here, you're doing the opposite of the input. So any negative number becomes positive. So you can think of it this way. Absolute value of x is the same thing as x if x is greater than or equal to 0, or negative x if x is less than 0. So that says if you have 0 or a positive number, the absolute value of that number is the original number. But if you have a negative value, then you're taking the opposite and making it positive. So you can think of this function as two pieces. And this point here where the two pieces meet, that is called the vertex. So you're going to look at different transformations you can do to this function. You can translate it, you can reflect it, you can stretch or shrink it just like any other function. And there's a lot of that explained in the lessons. Let's take a look at this GeoGebra graph. And this is in your lesson, so you should definitely look at this on your own as well. So what we're going to do is we're going to look at the transformations of an absolute value function. Right now it's the parent function it's called. There are no transformations. It's just f of x equals 1, absolute value of x, and then these zeros are just placeholders. So let's look at what happens when I increase the a value. Notice that changes the slope of the graph, and we're stretching it vertically. So I'm going to decrease a, it widens out, the slope is decreasing. You can see a very wide graph at this point. Then I'm going to keep going, a goes negative. Now, not only am I vertically stretching or shrinking, but I'm also reflecting. So when you have a negative a value, that's a reflection. And look at this one, this is a vertical reflection and a vertical stretch by 2.3 right now. If I move back to, say, this position here, that is simply a vertical shrink by a factor of 0.3. Okay, I'll put that back. Now let's look at the h and the k value. The h value, notice that the graph is moving to the right, and what's happening here is the number's changing inside the absolute value bracket. It's at -2, so -2 is 2 to the right. So that's a translation, 2 to the right, now 3 to the right. Now look what happens when I go to the left. It says x minus negative 1, for example, that's 1 to the left. And really, you would simplify that as x plus 1. See if I can get that back. Okay, right there. So x minus negative 1, that's really x plus 1 is how you would write it. But this graph does a double negative because it isn't smart enough to do the plus, but you're smart enough. So let's leave it on x minus negative 3 or x plus 3, just for now. Now let's adjust the k value. That's a translation up, c plus 2 right there. And then if I decrease the k value, it becomes plus negative 2. Well, that's really minus 2. And again, you're smarter than the graph, so you can put minus 2. Oh, lost the 2. There it is. So that's how transformations work for an absolute value function. And also you're going to learn how to write an equation for a function that's graphed. And I would like to talk about that briefly. Okay, so here's a graph of an absolute value function, and let's figure out how to write the equation for that. So here's the vertex point right here. The coordinates are 4 and then 2. And let's look at the rate of change. It looks like right 1 up 2 is the pattern here for the increasing part. So you could kind of say the slope equals 2. That's a vertical stretch. So how do you write the function? Well, the function is this. F of x equals a absolute value x minus h plus k. Now the coordinates of the vertex are h, k. So I simply substitute those values in. And the a is the vertical stretch and or reflection. So f of x equals 2 as the value of x minus h. Now the x value of the vertex is 4, so it's going to be x minus 4. And then plus the k value, which is the 2, so plus 2. And that's how you write an absolute value function from a graph. So that's the big picture for this lesson.